All right, so I think this is recording. Let's take a look at these two equations. The directions say to solve it, and it also gives us a hint, helps us out saying make sure that you check for extraneous solutions. So we have to check our answers into the original equation. All right, so in number 7, let's get the square root by itself. So let's add 8 to each side. So on the left-hand side, I have the square root of 2x plus 19. And on the right-hand side, I have x plus 8. So to get rid of this square root, I need to square each side of the equation. When I do that, that operation is non-invertible and it introduces the possibility of extraneous solutions. On the left-hand side, that square root goes away. And on the right-hand side, exponents don't distribute, so make sure that you take x plus 8 times itself, and you'll get x squared plus 16x plus 64. So this is a quadratic equation, and we want this quadratic equation in standard form, and then from there we can try to either factor it or complete the square or use the quadratic formula. So if we take away 2x from each side, and if we take away 19 from each side, what would that be? 25? Let me. I don't. I'm embarrassed that I am not very good at mental arithmetic. 40. Yeah, that didn't look right to me. Not 25, but 45. So I look kind of stupid. I thought, man, that doesn't look right. All right. So now you have video proof that I'm an idiot. All right. Let's come up with two numbers that would multiply together give us 45, but yet when added give us 14. And 9 times 5 does the trick that if I have x plus 9 times x plus 5, that will multiply together to give me that quadratic equation. So this gives me possible solutions of -9 and -5. But we need to check those. We don't know, we're not ready to say that those are our final answer. We're just ready to say, hey, that's the final list of potential candidates that are solutions to this equation. All right. So let's check this -9. On the left-hand side, we have 2 times -9 plus 19 minus 8. And the big question is will that equal x? Well, we said that x was -9. So we've got 2 times -9, which is -18. But -18 plus 19 is 1, and the square root of 1 is 1. But 1 minus 8 is not equal to -9. So that's extraneous, and I'm going to throw that out of my solution set. It was a solution to that quadratic equation, but it's not a solution to the original equation. All right, so what about -5? Is that going to be a solution? Well, I don't know yet. I'm going to have to plug it in and see. I've got 2 times x, which is 2 times -5, plus 19, minus 8. And the big question is that equal to a -5? So positive 2 times -5 is -10. -10 plus 19 is 9. The square root of 9 is 3. And 3 minus 8 is -5. So that does check. And this is in my solution. So there's my final answer for number 7. So let's come in and take a look at the next one. We need to add 6 to each side to get the square root by itself. If you forget to do that and you square both sides, you won't eliminate that radical. If you jumped in and squared this and then squared the other side, when you multiply this binomial, you're not going to get rid of that radical. You're still going to have a radical term in there. That's why we have to isolate this and get this by itself. So the radical goes away. When you multiply by itself, remember that exponents don't distribute. This is x plus 6 times quantity x plus 6, x squared plus 12x plus 36. And let's get this in standard form. So if we subtract 2x from each side, if we subtract 15 from each side, and now if we try to factor this, if we can't factor it, we know we can complete the square or do the quadratic formula. But with this 1x squared, it's easy to, you don't have to necessarily, if you're more comfortable doing the x method, hey, that's fine. But x times x is x squared, and 7 times 3 is 21, while 7 plus 3 is 10. So this gives us possible solutions of -7 and -3. So we need to check both of those before we say that's our final answer. So if I check -7, then I come to the original equation and I replace x with -7. So I have 2 times a -7 plus 15 minus 6. And the question is, does that equal -7? Well, 2 times -7 is -14, plus 15 is 1, and the square root of 1 is 1, and 1 minus 6 does not equal -7. So this x equals -7 is an extraneous solution. We're not going to include it in our solution set. What about -3? Well, I don't know yet. If I plug in -3, on the left-hand side, I have 2 times -3 plus 15 minus 6. And the big question is, when we do that, will that equal x? Will that equal -3? So positive 2 times -3 is -6, plus 15 is 9, and the principal square root of 9 is 3. And 3 minus 6 does equal -3. So this is a solution to the original equation. So hey, I hope that helps, and I will talk to you later. Bye.